Today we're going to take a look at expanding and condensing logs. And we're going to take a look and we're going to look at something together and see if we can figure out what does this mean to expand and condense logs. So the first thing we're going to take a look at, oops, where did it go? Here it is. We're going to take a look at this. So we have two people, Abe and Mary here, are talking about logs. And hey, Mary, I was just thinking maybe we could distribute logs like this. So does the log of x plus b equal the log of x plus the log of b? So logs are kind of different. Logs are, exponents rewritten differently. So how do you guys think we could test that? Okay, so one way we could test it, so if this is true, the log of x plus 5 should equal the log of x plus the log of 5, right? Because that's what it's saying. Let's see if this works, okay? So we're going to go here, and let's see if we can test this. So if we were to graph these, whoops, oh no, where did that go? So if we were to grab the log of x plus 5, here's that. That should be the same as the log of x plus the log of 5. Well, by graphing it here, we just said, well, those two expressions here, they can't be equivalent. Those aren't equivalent here. So I definitely found that those are not equivalent. So let's see this. There's something going on here. Check what happens when you graph the log of 4x. So if we look at this, log base 2 of 4x. Here's our original, log base 2 of x, log base 2 of 4x. So what happened here? If we look at our graph, the dashed line up to this blue line here, those two, it looks like it's been moved up. So as they say there, that's a vertical translation. We moved it. And we know a vertical translation, we do some adding here. Because we know from our past things of translations, vertical means to add. So if we have two things here, so this first thing that we just figured out, it's a vertical translation. So if we have log base m of n of, let's see, ab, that equals log base a of m of a plus log base m of b. So multiplying is really the same as that vertical translation, that we move it up. So there's one rule of logs. So let's take a look at this next one here. What if, oops, that's not the one I want. We take a look at one where it is division. So if we look at this one, if we start with log base 2 of x, and I'm going to change the color here. I'm going to make that a blue line. And if we divide it by 4, how would you guys describe from the blue to black? Well, it's going down. And how do we say go down? Well, that's usually subtraction. So that's saying, well, we're subtracting it, like it's a vertical translation down. So log base 2 of x minus log base 2 of, oops. So in reality, division is the same as a vertical translation of going down. So a log rule here is if we have something divided, so log base m of a divided by b equals log base m of a minus log base m of b. Now in the last rule we're going to talk about is what if we have a power? So log base m of a to the power of b. Well, we know that this is really just like multiplying over and over again. So, because that's like ab, except we're multiplying log base m of a times log base m of a b times. And we know from before multiplying goes back to division. or it goes back to addition, so there's really b of those. So this is b log base m of a. So you might be looking at these and being like, Miss Husing, what in the world just happened? So I was hoping to show you a visual of why these rules work. So what we're going to do is we're going to take a look at some problems. So for example, if I said expand, and if I said expand log, and I might use base 10 of 2 to the third, what's a way you could expand that, write it out? Well, our exponent, we know, can go out in front from these rules up there. So a way to expand this would be 3 log base 2. If we had one to expand and I said log base 5 of 6x, well, we want to expand it, break it apart, so multiplying, if I go back up to that first rule, goes back to adding. So log base 5 of 6 plus log base 5 of x. And then if we had a division one, if I said log base 3 of x divided by 5, well, division, according to that second rule, and maybe I'll number these so you know what I'm talking about here, 1, 2, and 3. So number 2 we have a division, and that goes to subtraction. So log base 3 of x minus log base 3 of 5. And again, we can look at some of these with variables. So for example, what if I had log base 2 of mn cubed divided by v? Like there's a lot going on. We got multiplication, division, and power. So first thing we're going to do, let's break apart that division. Well, we know division goes to subtraction. So we could rewrite this one as log base 2 of mn to the third minus log base 2 of v. So we broke apart the division. Well, exponents we're going to do last, kind of the opposite of PEMDAS there. So we still have multiplying right here. So let's break apart that multiplying. Log base 2 of m plus log base 2 of n cubed minus log base 2 of v. And then the last thing we can do is we can bring that exponent out in front. So log base 2 of m plus 3 log base 2 of n minus log base 2 of v, and we've expanded it. Now we could go the other way too. We could be told like condense to a single log. So for example, on condensing ones, let's say we had log of 3 plus log of 5. Well, what did we say adding is? So adding, if we look up, that's rule number 1, adding went back to multiplying. So this is really log of 15. If we had log base 2 of 8 minus log base 2 of x, well, subtraction, again, if we look back up, subtraction is number 2. Subtraction, we went back to division. So this could be log base 2 of 8 divided by x. And then if you just had a simple number out in front, maybe we had x log, and I'll just do a common log of base 10 of 8. Well, that number out in front becomes an exponent. So log of 8 to the power of x. And just a reminder there, if there's no base, that's base 10. So let's see if we can get one a little bit more complicated. What if I had x log base 3 of 5 plus 2 log base 3 of 7 minus 5 log base 3 of a. So first thing you want to do is the exponent. So we're going to go the opposite way. So those numbers out in front become exponents. So log base 3 of 5 to the x plus log base 3 of 7 squared. minus log base 3 of a to the 5th. And now we read it like a book, left to right. So we take care of our adding first. Adding went to division. So we'll take or adding went to multiplication. So log base 3, 5 to the x times 7 squared, minus log base 3 of a to the 5th. And if you switch 7 squared to 49, that's totally fine. And now we just have minus. Well, minus, we take those parts that are after and rewrite it as a single log with division. So log base 3, 5x times 7 squared divided by a to the 5th.